All right, for problem 4, what you need to do is create 4 sequences in this function that satisfy a couple of requirements. The first of which is that all the sequences must have a power of 2 number of elements. So they must have 2, 4, 8, 16, and so on number of elements. And each element must be an exact power of 2 as well. So for example here, 1 is a power of 2, 2 to 0. 2 or 4 or 8 or 1 or 2, 4, any of those things work. Granted, they're just all powers of 2. And your sequence must also terminate with an infinity sentinel value. This value doesn't count integer length, of course. So for here, you have a length 4 value sequence. And you can declare your sequence either statically initialized like this, or using a for loop like this, whichever one you want. And they also have to satisfy the requirement where sequence 1 gives the right value when you're using average A to find the average of the sum. Sequence 2 has to work for average B. Sequence 3 has to work with average 3 or average C, and sequence 4 has to not work with any of the averages. And of course, none of them should also work with the naive average here. By the way, that means that sequence 1 can only work with average A and it fails on the other, and so on. So let's take a look at the averages. So these average functions are in your bits test. So you should examine them and try to glean some insight into why each of these fail and what pitfalls are they trying to solve. So for example, here the naive one is, well, pretty naive. It just adds every single number in the array and then divides at the end. And as we can see from lab 4, there are so many pitfalls for float summation, dividing, doing arithmetic, that this version, frankly, is just not very foolproof at all. So let's take a look at average A. Average A, you are actually, before you add each element to the sum, you're actually dividing by n the total number of elements, and then summing them. So the big thing to think about is, why does this form, what benefits does this form have over this naive form? And once you figure that out, you can construct a sequence that takes advantage of that safeguard, while the other ones don't take that safeguard. So similarly for average B, what happens here is you're making another copy of this array, and then you're sorting it with respect to this callback function, so comp float. And then after you sort it, you sum the sorted array in the naive way, so sum and divide. So the big thing here is, think about what this sorting callback does. So if you take a look up here at comp float, it's sorting it pretty much in ascending order, right? So when your float is sorted in ascending order, what does that do when you sum them one by one? And once you figure that out, you can write your sequence 2. And then lastly, for average C, it's pretty similar to average B. You make another copy and then you sort, but this time you're using a different sorting algorithm or sorting callback. And this sorting callback, it's got some absolute value going on, and then it's sorting, and you have to figure out why sorting by absolute value matters, and what impact that has when you add an element at a time using the naive way. And once you figure that out, you can write your sequence 3. And then after you write your sequences 1, 2, 3 for these 3 averages, and knowing which each pitfall they're safeguarding against, you can write your sequence 4, which fails on all of these. And then just add your sequences here and write up an explanation for each of your sequences as detailed on the assignment handout. And as long as you have insightful observations, then you should be fine for this assignment.